Okay, so to start this problem, we want to first look at the spring mass equation and go in and substitute in our constants and our functions that are given to us. So that equation is m times y double prime plus b times y prime plus k times y is equal to 0 because we have no forcing in any of these first few problems here. And then we can take our mass, which is going to be 0.25. And again, that's times y double prime. They tell us that there is no damping going on in the problem. So because there is no damping, it's undamped right here. We know that it's going to be a 0 in place of b. So that's going to be just plus 0 times y prime. And then the k number is given to us as 1 Newton per meter. So that's going to be 1 times y prime. Sorry, just plain y. And that is equal to 0. All right, so now we can ignore the middle term, and that just turns into 0.25 y double prime plus y is equal to 0. If we multiply this equation through by 4 on both sides, we end up with our equation y double prime plus 4 times y is equal to 0. And now let's look at our initial conditions. So the first initial condition they tell us is that it's going to be moved 2 meters to the right of the equilibrium. So in all these problems, the right side is the positive side and the left side is the negative side. So that means that y of 0 is equal to 2. And now we have to look at our initial velocity. They say it's to the left at 1 meter per second. So that's going to be y prime of 0. And that's going to be a negative 1. Because again, it's moving to the left. So that is our initial value problem, and now we need to solve it. So first step in solving that problem, of course, is writing down the corresponding auxiliary equation. That's r squared plus 4 is equal to 0. So that makes our r equal to plus or minus 2 times I. So our general solution is going to be y of t is a c1 cosine of 2t plus a c2 sine of 2t. And now we need to find the values of c1 and c2. So we first know that y of 0 is equal to 2. So that says that c1 cosine of 0, which is 1, plus c2 times the sine of 2 times 0, which is 0, is equal to 2. That gives us c1 equal to 2. And now we know that y prime of 0 must equal negative 1. Well, y prime of t is a negative 2 c1 sine of 2t plus a 2 c2 cosine of 2t. And again, that came from differentiating our y of t that we have. We now substitute in y prime of 0. So that's negative 2 times our c1, which is 2, times 0, plus 2 times c2 times the cosine of 0, and that equals negative 1. So 2 c2 equals negative 1, so c2 is negative 1 half. So our solution is y of t is equal to 2 cosine of 2t minus 1 half the sine of 2t. And then for the next part of this problem, we're going to go in and take the solution and write it in a simplified form and then answer the rest of the questions in the problem.